Trig identity day 2. So Trig. And today we are going to talk about the even odd identities. So, even odd identities. And what we get from even odd identities is we have to think of the unit circle, always going back to our unit circle here. And let's think about theta, okay? So if we had theta, and theta is positive, so if theta is positive, it's going this way, right? So if theta is positive, it goes this way and it lands here. But what if theta is negative? What if theta is negative? If theta is negative, then it goes down and it lands here. So let's think about what that does to our trig identities. Our signs, when theta is positive, but when our sign, when theta is negative, right? Our sign is our y value. Our y value goes down. So that makes our sign negative. Sine of theta is negative. Our cosine is our x value. Well, when theta is going down, even though it's going down, our cosine is still in going forward, right? Our cosine being our x value. Our x value, in this case, is still positive. So our cosine is still positive. And then our tangent. Our tangent is our sine over cosine, negative sine over positive cosine. That gives us a negative tangent. And then, of course, the signs of our inverse should match our original. So then our cosecant will match our sine. Our secant should match our cosine. And our cotangent will match our tangent. So in this case, our even odd identities, if we have a negative theta, the signs will change for all except for cosine. So let's put some of this into practice. Let's put some of this into practice and try to verify some identity. Let's say that, well, let's verify the first one, right? Well, let's verify our first one where I said that the negative tangent of theta. So let's say negative tangent of theta or negative tangent of x must equal sine of negative x over cosine of negative x. Well, we already know, I'm just gonna, all you have to do is manipulate one side. I am going to manipulate the right side in this case. I know sine of negative x is going to be negative sine of x, and then cosine of x is just plain old cosine of x. And sine over cosine is tangent of x. So this equals negative tangent of x. So here we have negative tangent of x and tangent of x. And that is how we would prove it using our negative sines and cosines of x. Let's try some other types. Let's say I have, for example, a cosine of negative x, and I want to multiply that by cosine of negative x. And I want to subtract that from sine of x with sine of negative x. I'm going to simplify this to see what this could result as. I know cosine of x, negative x, and cosine of negative x, those I can change to simply cosine of x times cosine of x. Sine of x stays the same. Sine of negative x becomes negative sine of x. So that will change my sign in the middle to a positive. So this becomes the sine of x. If I combine them, then I get cosine squared of x plus my sine squared of x. And I already know that cosine squared and sine squared of x, it's a Pythagorean identity, simplifies to make just one.